In our next section, we're going to take a look at radical equations. So the first problem that we've got is the square root of x plus 7 equals 16. What we want to do is the same set of processes that we've always done for solving any equation. And that is to isolate the variable by using the reverse order of operations, or the opposite of the order of operations. So instead of ending with addition and subtraction, we're going to begin with addition and subtraction. So we can see that we've got a plus 7 being added to the radical. So we want to get rid of that positive 7. So we're going to subtract 7 from both sides. And that's going to leave the square root of x is equal to 9. Now, you have to remember, what is the opposite of a square root? The opposite of a square root is a square. So how do we remove a square root? We square it. So if you square this side, then you're also going to square this side. The square and the square root are going to eliminate each other. You're left with just x on the left side, and then 9 squared is 81. Now to go back and check to see if you got the correct solution, plug 81 in for x. So we get the square root of 81 plus 7 equals 16. Now that we're checking, now use the order of operations. So we start underneath the radical first. The square root of 81 is 9, plus 7 is 16, and 16 equals 16. So we know 81 is the correct solution. For the word problem in number 2, I've modified the problem just a little bit. I've taken the 3.3 that was in the book and just replaced it with a 3. That way we're not having to worry about any calculations that we got to take a calculator out for, or we've got to do a lot of work by hand. I just want you to see the process of this. So what we're given is t equals 2 times the square root of L over 3. And we're told that t is equal to 3. So what we're going to do is we're going to change this t to a 3, and then we need to solve for the L. So the first thing that we're going to do is we're going to work outside of the radical to get rid of anything that's on the outside of it. So since we've got a 2 over here, we want to divide by 2. And so we're going to get 3 over 2 is equal to the square root of L over 3. Now in order to get rid of the square root, again, we're going to do the opposite of a square root, which is a square. So square this side and square the other side. So now this becomes 9 over 4, and that's equal to L over 3. So now what you could do is you can work this a couple of different ways. You could treat this as a proportion and do cross multiplication, or you could continue on by isolating L. I'm just going to go ahead and continue on by isolating L. Since I know that L is being divided by 3, to get rid of that division, I want to multiply by 3. So I'm going to multiply this side by 3 and multiply this side by 3. When I do that, these 3's cancel out, and I'm left with just L. And then over here, 3 times 9 is 27, so I get 27 over 4. And that's going to be your solution for this problem. All right, so for problem number 3, we've got radicals on both sides of this equation. What we're going to look to do here is to just get rid of these radicals. But whenever you see this setup, you should have alarm bells going off that there's a possibility that your answer or answers may not be the correct ones. These are what we call extraneous solutions. So you always want to go back and check your answers, plug them into the original equation to see if they work. Now, that's not going to happen 100% of the time. So there are going to be times when you've got a setup that looks like it might give you an extraneous solution, when it actually offers you only true solutions. But you've got to go back and check anyways just to make sure. So we've got the square root of 5t minus 11 equals the square root of t plus 5. We've got variables on both sides and we've got radicals on both sides. So at this point, just go ahead and square both sides. So we're going to square this side and this side because that square and that square root are going to cancel each other out. So now we're going to be left with 5t minus 11 equals t plus 5. So once you've got this set up now, you're just looking to get everything to one, or to get all of the variables to one side. And so when we're looking to get the variables to one side, I would again suggest move the smaller variable, or move the variable with the smaller coefficient. In this case, it's the 1t. So I'm going to subtract t from both sides. And again, what this does is it guarantees that my variable is going to remain positive. So I don't have any special rules or anything that I've got to remember, especially if we're dealing with inequalities. So 4t minus 11 equals 5. Add 11 to both sides. You're going to get 4t is equal now to 16. Divide out the 4. And so t is equal to 4. Now again, go back and check this and make sure that your work is correct, because this solution could be correct or it could be extraneous. So we're going to go the square root of 5 times 4 minus 11 is equal to the square root of 4 plus 5. So 5 times 4 is 20, minus 11 is 9, so we get the square root of 9 equals square root of 4 plus 5, the square root of 9. We can stop right there because we can see that we've got equivalent sides, and we know that then that t equals 4 is the correct solution. Problem number 5 gives us a case where we're going to have to isolate a radical, and then we're going to have to isolate the variable after that. So let's take a look at how we're going to accomplish that. We've got a positive 8 sitting out here being added to our radical. So we want to get rid of that first by moving that to the right side. So we get minus 8 and minus 8. So now we've got the square root of 3y is equal to negative 6. So the next thing that we're going to do here is we need to get rid of that radical. So again, to take care of that square root, we're going to square both sides. And when we square both sides, we're going to be left with 3y is equal to 36. Now, just isolate the variable. Divide by 3, and y is equal to 12. Now let's go back and make sure that our solution of 12 is the correct solution. So plug it in for y. 3 times 12 is 36. Take the square root of 36, and that gives you 6. 6 plus 8 is 14. It's not 2, so we know y cannot be equal to 12.